Exploring the Solar System Part 3, how we study the solar system using telescopes on or close to the Earth. So telescopes have been around for 400 years. I'll give a very fast history of that. Think about what we saw of the solar system with the very early telescopes and what we're seeing now with the latest telescopes. And again, we can ask the question, what next? So Galileo didn't invent the telescope, but he was one of the first to point the telescope at the sky and realise that it's actually quite interesting. If you look at these bright points of light that we call planets, they turn out to be interesting worlds in their own right. Since then, telescopes have changed. Generally speaking, the apertures have got larger and larger and larger, and we've changed from using lenses to using mirrors. In the last century or so, we've had the 2.5 metre or 100-inch Hooker telescope, which ultimately then evolved into something like this, the 5 metre or 200-inch telescope in Palomar Mountain of America. As it happens, the largest telescope in the world when I was born, and the largest telescope in the world for all of my childhood and quite a bit of my adult life as well. But now, of course, we're used to the idea that we've also got telescopes not just sitting on the surface of the Earth. We also have space telescopes such as the Hubble and the James Webb Space Telescopes. But it won't be long, just a few years now, before we have an evolution of monster telescopes with mirrors that are absolutely huge compared to what we're used to. The European Extremely Large Telescope there with a mirror approximately 40 meters in diameter. Perhaps you can't see, but there's some people that give it scale. Those tiny little dots in the foreground there are a couple of people there. So let's remind ourselves what Galileo saw when he pointed his early telescope towards the sky. When we look at Jupiter, our own eyes show us 4 stars which wander around Jupiter, as does the moon around the Earth. He realized that the Earth is not the center of the solar system, not the center of the universe, because some objects seem to go around Jupiter, not go around the Earth. So night on night, he made a note of Jupiter and these little attendant 4 stars. Occasionally there were genuine stars in the background, but he effectively monitored what we now call the Galilean moons night after night, and he showed that you could work out the period of each of those dots in terms of how long they took to go around Jupiter. And after a while you can start to predict where these moons are going to be. So a very important discovery showing that the Earth is not the center of everything. When it came to try and understand what's going on with Saturn, well, confusion reigned. The first sight that I had of Saturn was of 3 round stars, the one in the middle considerably larger than the other 2, the 2 lateral ones. So it looked like Saturn had ears or something. And indeed, a lot of the telescopes at the time, a number of different observers started looking at Saturn, and they all got slightly different answers in terms of what it is that you think you're looking at. That was Galileo's 1610, but at the time people were undecided as to whether it genuinely had 2 blobs either side, whether it had ears, whether it had handles, and so a lot of different sketches give you an idea of the possible models for what we thought Saturn actually looked like. Most of this was the result of telescopes that were not what we would call perfect, not optically perfect. They had aberrations because it was difficult to make lenses of the right shapes. And therefore, it wasn't necessarily just the seeing conditions, it was literally the quality of the telescope that made it difficult to see what was going on. But by 1659, Huygens said, well, of all the observations we've got so far, I think what we're actually looking at is a sphere with a flat disk around it. And what we can see of the observations are just the result of imperfections in the telescope. And of course, that model, if you like, of what we think Saturn's rings look like, that's been borne out by modern day observations. Huygens in 1659 was basically right. But as well as confusion as to what's going on with Saturn, there was confusion with Mars as well. So Giordini Schiaparelli made observations of Mars. You can see his notebook here. wonderful idea of little bits of paper, scrap paper, held in with postage stamps, and he made observations of features on Mars, some of which are blown up on the right hand side there. It looked like he was seeing linear features on Mars, which he reported in the late 1800s, this particular notebook showing a page from 1890. So he saw these lines or channels, or as he said in his native language, canali. But canali unfortunately got mistranslated. So maps of the time showed various features on Mars, including these straight lines of canali. But unfortunately, these canali got mistranslated, and what should have been channels ended up as canals by the time they came over to Europe and America, the rest of Europe and America. And this was picked up by a number of people, including Percival Lowell, especially in the late 1890s. He was convinced that these canals really did exist, and if they're canals, they must be artificial, and if they're artificial, somebody must have built them. And hence we had this explosion of ideas. There can be no doubt that living beings inhabit our neighbour world. So the New York Times here describes Percival Lowell as being recognised as the greatest authority on the subject. I don't know who said he was the greatest authority, maybe he did. But not everybody believed that there were these canals. Some people saw them, and some people said, well, I look at my telescope and I can't really see these lines. So there was a lot of controversy. But as soon as you start talking about Martians existing and making these canals for irrigation purposes, then you get the War of the Worlds, you get the book, and ultimately the paranoia of the idea that we are possibly being invaded by Martians. There's the telescope that Lowell used in the Flagstaff Observatory. There's an image of him at the business end of the telescope. What's thought to be happening is probably, because we're talking about a large telescope here, the lens, as it was at the time, 24 inches in diameter, collecting an awful lot of light, and everything is being funneled down to a small eyepiece at the business end there. So it's probable that a lot of light was being focused into a small eyepiece, and when you put your eye to the eyepiece, like when you go to the optician and they shine a bright light in your eye, you see the blood vessels on the back of your eye. Maybe people were being fooled into thinking they were seeing some linear features on Mars, even though they were actually seeing blood vessels in their own eyes. So although Schiaparelli and a few others said, I think I can see linear features, it wasn't many years before people were saying, yes, there are features on Mars, but I don't actually think they're straight lines. I think if you see straight lines, that's a function of your eyes, not a function of what's actually out there. So globes of Mars that showed canals eventually morphed into something closer to what we see today. There's a picture from the Hubble Space Telescope, clearly showing variations in contrast and ice caps, but not showing any linear features that could be interpreted as canals. Now, as I'm sure you're aware, amateur telescopes have evolved a lot over the years. There's always a drive to get larger and larger apertures, because then we can collect more light and see fainter objects, and larger apertures give us better definition, so we can see more detail in objects. And so any so-called dioptric systems that use lenses, well, we tend to call those refractors, and catoptric telescopes that use mirrors, we tend to just call those reflectors. And any telescopes that use some combination of glass and mirrors, lenses and mirrors, we tend to call those catadioptrics, or CATs for short. And of course, everybody would like to have, ideally, the largest telescope they could afford, or perhaps the largest telescope they can lift, because amateur telescopes have come an awful long way in past decades. And this one, for instance, is not only very big, it is very expensive. I think this particular one is something like 300 kilograms, not the sort of thing that you can just pick up and lift out into the garden, but clearly this one is on a tripod, so it's not necessarily permanently mounted. I can't remember the cost of this, but it's clearly not cheap. So amateurs always want the largest aperture telescope they can get hold of, but of course professionals are exactly the same. Ever since Galileo first started to observe the skies, professional astronomers have wanted larger and larger apertures. So this graphic simply gives an indication of the relative sizes of the largest telescopes. Way in the top left there is the largest refracting telescope. That's a 1 meter diameter lens. Everything else on this graphic shows you the relative sizes of the mirrors that have been used over the last 100 years or so. And just to give scale, there's in the very bottom left, there's a tennis court peeking out from the bottom, and in the bottom right, there's a basketball court peeking out, just to give you an idea of scale. The largest telescope in the world at the moment is Gran Telescopio Canarias, shown there at the top in yellow. It's got a diameter, if you can call it that, because it's actually made of hexagonal segments. It's got a diameter of approximately 10 meters. And there are a number of telescopes of a similar sort of size, but that is the largest one. In the bottom left, we have the space telescopes. James Webb is about 6 meters in diameter. Gaia is significantly smaller, Kepler smaller, and Hubble is only about 2.5 meters in diameter, its main mirror. But you can see from the graphics on the right-hand side that it won't be long before we have absolutely monster-sized telescopes. We're struggling to come up with decent names, so we've got silly names like the Extremely Large Telescope, the ELT. Hopefully operational somewhere around 2028. It's slipped a bit because of COVID and a few other factors, but hopefully around 2028 it should be operational. And it's amazing to think what we will be able to see when we collect light over such an enormous area. So when I was born, the largest telescope in the world was the 5 meter Hale telescope, built in the 1930s, 40s. And it wasn't overtaken as the world's largest telescope for about half a century. But now things are moving apace. Where do you put these telescopes? Well, the best observatory sites in the world are considered to be either the volcanic islands of Hawaii and the Canary Islands, so La Palma and Tenerife, or alternatively to volcanic islands. An alternative is to put them in the high desert of the Atacama. Very high and very dry, so very little water vapor to spoil your views of the universe. But if you, let's just give an idea of where that is in Chile and just an idea of what it looks like. That's an observatory on one mountain taken from an observatory on another mountain. You can see that although when you look down you see cloud and mist and haze, essentially that's all below you. Because if you're on a high enough mountain or plateau, you tend to be above most of the haze of the atmosphere, and there's still some air above you, but hopefully if most of it is below you, you get a nice clear view of the sky. But if that's not enough for you, for instance, if you wanted to do infrared astronomy, then even that amount of atmosphere above you would still absorb a lot of the light, so you'd want to be higher still. And one option is to put the telescope in the back of a 747 and fly it at 10,000 meters, higher than Everest, for instance. So SOFIA, the Stratospheric Observatory for Infrared Astronomy, was operational for many a year and has now been retired. Partly because James Webb Space Telescope is an infrared telescope outside the Earth's atmosphere, so it can do a better job. So this 747 has been retired, so watch out on eBay if anybody wants to buy one. And of course we're all familiar with the now 35-year-old Hubble Space Telescope, which has been operating for most of those 35 years and hopefully has got a few more years ahead of it in terms of taking data in the visible part of the spectrum. And of course in 2021 on Christmas Day, the James Webb Space Telescope was launched with a hexagonal folding mirror. It was tested on Earth and then folded up, as in the central panel there, the origami to fold up the mirror, fold up the sun shield, put it on top of a rocket and then launch it to a particular parking place called L2, Lagrangian point 2, which is a great place to put telescopes to allow them to see the universe without getting too much heat from the moon or the earth or the sun. That's why there's a sun shield there to keep it nice and cool, because it's an infrared telescope. We don't want any heat getting in the way of our scientific observations. If we compare what does the Hubble Space Telescope see of Jupiter compared to the James Webb Space Telescope, James Webb is working in the infrared and we can colour the image how we like. It doesn't really matter what colours we use, but the point is we see different detail. In the case of Hubble Space Telescope, the colours are indicative of different compounds, probably sulfur compounds and phosphorus compounds that might be at different depths in the cloud layer. In the case of James Webb Space Telescope, depending on what infrared frequency or wavelength we choose, we can see the absorption of particular molecules like methane or ammonia or other compounds. And in this particular case, perhaps you can see a touch of red at the top and at the bottom. That's not any aberration in the telescope, that is all genuine. This is northern and southern lights. This is basically aurora on Jupiter. Because Jupiter has a strong magnetic field, it has aurora much like the Earth does. If we compare a visual or visible picture taken by the Hubble Space Telescope of Saturn and compare that with James Webb, they again are very different. Because this particular wavelength has been chosen such that we are seeing a lot of infrared light being absorbed by the planet. The planet has got quite a lot of methane in it, and this particular wavelength, the light is being absorbed. Whereas it's clear that the ring system appears to be quite bright, because the ring system is reflecting a lot of the infrared light, because it's effectively a collection of icy particles which are very reflective. So we get this rather odd result of a rather dark planet and a very bright set of rings. And that's true for other planets as well, like Uranus. We knew the rings existed, but James Webb Space Telescope, by choosing the right wavelength, can see the rings very brightly because the rings reflect infrared rather more efficiently than the planet does. So we wouldn't expect to see the rings this bright in visible light, but the James Webb can pick them out easily. It also looks like it's picked out a bit of a storm system raging there on the side, something that Voyager didn't see when it flew past Uranus. Bear in mind the speed at which Voyager was travelling, it only had a few hours to pass Uranus, whereas with telescopes like this we can choose to look at the planets as often as we like, effectively. And again, similar sort of idea here, Neptune. Neptune with its rings, rather faint rings, but again they show up in the infrared. And what looks like a very bright star in the background actually is just one of the moons of Neptune. It's Triton. And Triton appears to outshine Neptune, even though it's tiny, simply because, again, Neptune is actually absorbing quite a bit of light, but Triton is effectively solid nitrogen on the surface and is very reflective at this particular wavelength. So Triton actually looks a lot brighter than its parent planet. So what next? Well, there are a number of telescopes that will be coming online soon. I've got this written as under construction, but effectively the construction is essentially complete. The Large Synoptic Survey Telescope, this particular telescope is called the Chamonix Telescope. It's in the Rubin Observatory, the Vera C. Rubin Observatory. The Chamonix Telescope has got an 8-meter diameter mirror, and it's going to be performing the legacy survey of space and time, and it's basically going to be mapping out what's out there. It's going to be looking at everything. It'll be looking at stars and galaxies, but along the way, it will also see lots of solar system objects. It will almost certainly detect thousands upon thousands of asteroids. It'll probably detect a few thousand in every image that it takes. And it will be picking up a whole load of new objects we didn't know about. If Planet 9 is out there, for instance, a planet beyond Pluto, well, this will pick it up. Its camera is quite large. This is simply a graphic giving you an idea of the size of the camera compared to a human. the 10-year survey that it's going to be doing, effectively mapping out the sky every few nights and then continually remapping to see, are things changing, are things moving, are they part of our solar system, are they stars changing brightness, are they galaxies containing stars that are going supernova, etc. It'll be mapping out the sky over and over and over again for 10 years. The dates there say 2025 to 2035. Perhaps it won't start the survey till next year, but it's almost ready to go. And the other one I've already mentioned is the European Extremely Large Telescope, hopefully operational in 2028. And again, I just point out for scale, there's a couple of people on this platform and there's a couple standing outside there. So something like a 40-meter diameter mirror. It's going to be picking up the faintest light from galaxies across the universe, but if there's anything in the solar system that's worth a closer look, then this telescope can be tasked to look at even the faintest objects that are out there. So again, if I piqued your interest, you can go and find historical information about the Hubble Space Telescope and what it's been doing for the last 35 years from Hubble site. James Webb is obviously at the relatively early stages of its life, having been launched in 2021, and it's got hopefully many, many years of life ahead of it. And the two new telescopes that are just about to come online, the LSST and the Extremely Large Telescope of the European Southern Observatory, those web pages are there, and again I'll make them available to you if you want to go and find out more about what telescopes have been doing and what telescopes could be doing in the future to tell us more about the solar system. Thank you very much.